So here comes to the fourth section of today, ASTRI V2X Technology for Connected Vehicles. Now, ladies and gentlemen, please give a big clap to our speaker, Dr. Billy Chen, Senior Manager, Communication Technologies, Hong Kong, ASTRI Limited. Thank you, Billy.
Okay, good afternoon, everyone. Thanks for the ladies. Thanks for the university. Today it's difficult to be the last speaker usually in the talk because everyone should be tired and also exhausted after a long day event. But don't worry, I will try to make my presentation to be very concise, and hopefully when you are leaving this, you can get something useful after the talk. Let me introduce myself. I'm Billy. I'm from the ASTRI. This is the Hong Kong government-funded, the largest R&D center in Hong Kong. We are actually doing different communication technologies. So today's topic, I'd like to talk about the V2X technologies, which is called the vehicle-to-everything communications technologies for connected vehicles. Okay. For your background information, V2X is actually one of the 5G industrial trend and focus. V2X stands for Vehicle to Everything Communications. It is the 5G technology trend with the focus of ultra reliability and also the low latency communications. In our definition, IoV, Internet of Vehicles, or Connected Vehicles, or V2X system, is actually defined as a dynamic mobile communication system between the vehicles, between the public networks, between the infrastructure, and also the internet. And they are using different communications. For example, we have the V2X. V2X stands for, consists of the vehicle-to-vehicle communication, V2V, vehicles to pedestrian communication, V2P, V2I, vehicle to the infrastructure, and also vehicle to the networks. And there are two major standards right now in the world for the V2X standard. One is for the LTE V2X, which is from the cellular network, from the mobile networks. And also we have the DSLC from the Wi-Fi based from the IEEE, which is called the L2 11P standards. And for this communications system, we can enable different kinds of applications. For example, for the road and car status monitoring, to provide the remote diagnostics for the drivers, and also for when there are some emergency on the road, we can provide a remote assistance to drivers. And also we can using the V2X technology to enable the road safety and also smart mobility and also different kinds of applications like the fleet management, which is useful for different end users like the bus company, like the logistic company, even for the insurance company, because they can monitor the driver behavior from their point of view. And the statistics gathered from this V2X networking system can be useful for the government agencies like the transport department to do different kinds of traffic policy. So in brief, introduce what is V2X. As I said, V2X actually consists of V2P, V2V, V2I, and also V2N communications. We can use the V2X technologies to enable different wireless connectivity in order to enable the so-called connected vehicles. When we talk about the connected vehicles, we are talking about connected vehicles to the internet. That means we have the Internet of Vehicles, the 車聯網. And also we can achieve the so-called cooperative awareness but between the vehicles, because the vehicle can talk to each other. They can share the data between each other. They can establish the knowledge about the environment, about on the road. So we can realize different types of useful scenarios or applications. For example, for ASTRI, they actually define several, like 23 road safety use cases for us to do the different kinds of applications and scenarios. And if you look at, so why do we need the V2X technology? Because if you look at the existing solution or system, they are mostly for the vehicle resident solutions. That means they are using the onboard sensors to see the environments. For example, they are using the radars, they are using the LiDAR, and also using the camera to see the roads, to do different kinds of analysis in order to make the decisions, which is mostly from the vehicle's point of, in-vehicle perspective only. But V2X, if V2X is in place, that means you can add one additional source to the driver, to the system, and you can actually complement and enhance the existing vehicle resident solution. In what way? For example, because we can use the surrounding information between the vehicles, we can also get the data from the roadside unit, from the roadside infrastructure. That means we can establish the knowledge between the vehicles, and also we can know the environments. Then we can use the V2X technology because we can see around the corners, right? Because if we can, for example, especially when there is a long line of sight situation, we can place the roadside unit in the intersection point, and then it can help to relay the data between the vehicles. We can see you can see around the corners, and then we can also see through other vehicles. Imagine that there are a string of vehicles, like the platooning situation. The head vehicles can exchange the data with the rear vehicles, and they can know each other, the position, the location information from each other, so that they can predict the path of the surrounding vehicles. And most important is that when using the V2X communication, it is resilient to the weather conditions and also to the poor lighting situation or some sensor cleanliness. Because for some camera-based system, it does not operate correctly or properly if mostly at the light situation or poor lighting situation. But with V2X technologies, we can provide a longer effective communication range, and also for a longer reaction time for the driver to react before the accident. We are not trying to compete with the existing V2X vehicle register solution, but we are trying to complement and enhance the existing system, because together with the in-car sensors data and also from the vehicles data exchange, we can provide a richer information in order to assist the system or the car to support more advanced capabilities or advanced applications, for example, for the future autonomous driving. For autonomous driving, vehicle communication is one of the key components in order to enable these kind of applications. Okay, so if you look at the market, actually for IOV or V2X, there is a huge global market, especially in China or Asia Pacific areas. And for automotive V2X market, it is expected to reach a number of 2.8 US dollars in the 2022, and most of with a higher growth rate in the Asia Pacific areas. Also, we have the automotive market will contribute like the total China GDP of 20%, 29% of total China GDP for the next 10 years. It is the second largest among the consumer electronics. So every car manufacturers, operators, equipment vendors, and also service providers, they are looking into this V2X market. If we talk about the development status for the V2X, as I mentioned, there are two major campaigns for the standard. One is from the IEEE, which is a Wi-Fi-based AO211p standard. This is also called the DSRC, the Dedicated Short Range Communications. This is operated in the 5.98 gigahertz spectrum, which is the ITS spectrum actually. And recently in US, they have a new policy to maintain by 2023, all the new produced vehicles have to be equipped with this DSRC equipment in order to release to the market. So this is very beneficial to the aftermarket equipment for the DSRC product. And another campaign, of course, is from the cellular, from the mobile networks, which is from the 3GPP. We are talking about LTE V2X, okay, and also so-called the cellular V2X. And there is the initial draft for last year, the last September. They based on try to talk about the V2X direct communication between the vehicle to vehicle. And in last month, just the release 14 in LTE release 14 specifications, they released the full set of the V2X, involved the V2I and also the V2N communications. And there is an enhanced version called the LTE V2X, will be in the release 15. We will be in the 2018 timeline. And there is from the automotive industry or the telecom operators, they also set up the associations, so-called the 5G AA, 5G Automotive Associations. They want to develop Audi actually is one of the key members. They want to develop the key testing the V2X communication and also specify the strong evolution to the 5G technologies. And there is also another organization, so-called the Next Generation Mobile Network Communications. This is an NGMN. They have a V2X task force. ASTRI is one of the members. They actually established by the telecom operators industry. And in 2016, the aim is to do the technology evaluation between the DSRC, between the LTE V2X standards. They want to compare the advantage, between the two standards. And also, they want to perform some trials, testing results, and propose the possible business models for promoting the LTE V2X and also to the 5G technologies. We are actually partnered with different operators, equipment vendors, and participating in this kind of professional activities as well. Okay, so you may heard recently we have a news in Hong Kong just last month in the March. We have set up a so-called Smart Mobility Consortium in Hong Kong. This actually is a joint R&D force with our partners. We have our partners Hong Kong T, Huawei, and Qualcomm. We set up a consortium in order to promote, to utilize the power of the CV2X, the cellular V2X, in order to enable different smart mobility and safe mobility technologies in Hong Kong. We want to do some trials in Hong Kong in order to showcase that we can apply this kind of technology in Hong Kong and do the possible deployment later. And for the role of different partners, actually, if you know that actually Qualcomm is the chipset vendor. So in the future, actually they are making the chipset for the LTE V2X. So in the future, you are using your smartphone with the V2X capability, and then you can talk to the vehicle. So this is so-called the V2P communications, okay? And for the Hong Kong, they provide the network, they provide the service to the users. Huawei will provide the communication technologies for the terminals, like the user terminal, which is installed in the car, and also the RSU, the road sound unit, which is installed in the infrastructure. They build the infrastructure, okay? And ASTRI, our company, we mainly focus on the R&D. We develop the V2X networking system in order to realize different applications and also different use case development to be deployed in these networks. And of course, we need to have a car vendor, okay? So to build a complete end-to-end ecosystem in order to promote the connected vehicles and also the IOV or the V2X technologies in Hong Kong. So let's talk about the more technical details about our technologies, which is the V2X networking system. Okay, we'll do it in an end-to-end perspective. Okay, so we'll start from the vehicles. Of course, we have the vehicles, right? We have the vehicles. We have the in-car gateway software, which can retrieve the data through the OBD interface. Because for every vehicles, they will be encrypted with the standard OBD interface. We can use this interface to retrieve the data. So what kind of data you can expect? This is the dashboard information, like the speed, the rotation, different sensor, different temperature values. And then our in-car gateway can actually receive this data, and then we will integrate with the LTE communication technologies, communication terminals. Like for example, Huawei, we are using Huawei UE, and then we will enable the communication between the vehicle to vehicle. Okay, this is a vehicle-to-vehicle, V2V. And then we also have the pedestrian. Pedestrian, we're using their smartphone. They will carry a V2X device with the V2X capabilities. And then we provide the mobile app for them as a user interface for them to communicate between our vehicles and the pedestrian. So this enables the V2P communications. And for our gateway, we will also connect it to the network infrastructure. We have the RSU actually installed on the roadside, or in 3GPP, actually it is the base station. It is a E-Loop-B. So we have the edge, so-called the edge gateway software, running on the top of this RSU, and then it can actually help to relay the data from one vehicle to other vehicles. This is usually for the intersection case when the vehicles cannot do the direct communication. They need to have a relay. So they need to have a RSU installed and help to relay the data from one vehicle to another vehicles, okay? And also we have the edge gateway. They can do the application processing for trigger some alarms. For example, imagine an intersection case when two vehicles actually approaching the intersection. They cannot see each other, and there is a potential hazard for the collision, for the accidents. So our edge gateway will actually send the alert to the driver, to the car, and then to alert them to slow down in order to avoid the accidents. So our edge gateway can do this kind of application processing and trigger the alarm. Also, the data will be sent to our V2X, the back-end system, the V2X management system, and it can enable different applications like the fleet management applications and all different kinds of IoT applications. And we have a web GUI, the user interface for the user to log into the system to operate, and we provide different features. Okay, and for some use cases, it actually involves the third-party system integrations. For example, some traffic management system or some parking system. So our system will also provide some so-called Launchpad application interface in order to integrate with all these kind of third-party application system. So you can see that this is the end-to-end effort, end-to-end integration effort, and also development effort. So we are responsible for doing this for our partners in order to build an end-to-end V2X system. Okay, and we also actually step back from the lower level. We also have a team doing the LTE baseband solutions. So they are actually doing the physical layer, the radio layer research. So this is mainly for the V2V communications. In 3GPP, they define the PC5 interface, which is for the so-called PC5 interface for the V2V vehicle-to-vehicle communications. And actually, they are operating in 4 modes, either from the in-coverage mode or in the out-of-coverage mode. They have 4 modes in these 2 kinds of operations. The difference is that for the in-coverage mode, there is a base station. The base station actually helps to do the synchronization between the vehicles. Okay, but if the vehicles or the UE cannot sense the base station, they are out of coverage. So they will do the out of coverage operations. And instead, they actually divide the mode 4 for the vehicles, direct communication for the mode 4 from the vehicles to vehicle communication. And how they do the synchronization, they will use the GPS, they will use directly from the car-to-car synchronization in order to get them the communication works. And also they define some high advanced features. For example, high mobility. Instead the mobility speed they define, the requirement is 250 kilometers. 250 kilometers, and also the relative speed will be the 500 kilometers hours. So it is very high speed in this kind of V2V communications. So this is the highlight of our V2X networking system. Our system actually consists of the gateway, consists of the back-end management system, and the characteristics that we have the open, which is an open and extendable platform. That means we can support multi-vendor, multi-standard, and also multi-protocols in our system. We already adapt the OBD standard. This is the standard OBD. We have the fleet management standard, and also we have the basic, like the BSDN, basic safety message standard from the SAE. And this support different kinds of vehicles, from the private vehicles, from the private car to the so-called heavy-duty vehicles, okay? And we can actually this is an open platform to integrate different kinds of sensors and devices into our gateway software, like the GPS, the Wi-Fi, CAN bus, beacon, display, and different cameras, okay? So what is V2X technology agnostic? Our system actually can support both standard in the V2X, like the DSRC-based standard, or also the LTE V2X standard. We are technology agnostic to the V2X. This is very important because in the future, just like the Wi-Fi and the LTE base, in our opinion, there will be a hybrid mode to exist in the world in the later. So we have to support both standard in order to support the so-called connected vehicles and also as well as the autonomous driving. And from the ROV management system, which is we can provide efficient data or the vehicle management. The focus will be on the fleet registration, authentication, and the access control. we have to ensure that only the authorized authorized vehicles can be registered into a system in order to get the data, in order to access the system. And we will protect the data because it is transferred over the internet. So we have to protect the integrity, and also we will do the encryption to protect the data. Of course, at our back end, we have the big data analysis, and we will trigger different alarms based on our algorithms, based on our application processing algorithms. And as I mentioned, we have the in-car gateway in the car, we have the edge gateway in the infrastructure, in the roadside unit, and they are running different software. We are actually integrating with different OBU, RSU, or even the mobile edge computing, okay? And we can trigger different alarm and notification to the users in order to provide different V2X communications. Of course, for the user to operate, we will provide a GUI, we will provide the mobile app, and there are different features like the vehicle status monitoring, map locations tracking, dashboard informations, alarms, emergency call, trip records, and also heat map. Different kinds of features that just like a general feature management system. And also we will provide the mobile app, mobile interface, which is actually as a user interface for the pedestrian to communicate with the vehicles, which is for the V2P communications, actually. Okay, so in 3GPP standard, actually it defines different use cases. We cannot do all the use cases, so we need to have a focus. We will focus on those road safety use cases. What are they? These are the example use cases. For example, for the V2V, we have two vehicles. For example, their head vehicles suddenly do the emergency brake, and then you can trigger the alarm, and then you send the alarm to the rear vehicle through the V2V channel. This is one of the typical case. And the other one is the V2P vulnerable road user warning. It's like when the pedestrian want to do the crossing, right? But it actually is behind a large vehicle or a large truck. The driver, the car cannot see it, actually. So the device or the smartphone actually will trigger the alarm to send it to the driver in order to alert there is a pedestrian crossing behind the vehicles on the road. And other ones like the V2I intersection alarm or the V2I emergency stop will also try to do all these kind of road safety use cases in order to cover both all the, for example, V2V, V2I, and also V2P communications using our system. I want to show you a video, but before that, I would like to give you some briefly description about what are the use cases that we want to demonstrate in order for you to understand more when you are watching the video. Okay, so this is we did the road test in the science part before, and this is the installation. You can see that the installation actually is very simple. This is our OBU. This is a DSRC system. This is DSRC system, and our software, in-car gateway software, actually running on this OBU. We are using the NXP OBU because they are our partners, okay? And then the power is actually using the car chargers, okay? The setup, and there is some GPS antennas on the car, and the setup is very simple, but it can actually allow the V2V, V2P, and also V2I communication already. So this is the GUI of our system, which is similar to the traditional the feature management system. We have the map, we report the real-time map and GPS location tracking. But then actually, because our gateway can retrieve the OBD data real-time, so we can report the real-time car dashboard information. This is a dashboard information, like what you're driving in the car. Okay, I also have other features like the trip records, heat map, the general features that offer from the feature management system. And this is one of the use cases I mentioned before for the V2V emergency stop, when one vehicle suddenly do the hard brake, do the emergency brake, and then the rear vehicle can receive the data, can receive the alarm from the head vehicle. Okay. This is another case we'll be showing in the video. It is called the V2I emergency call. Imagine that when there is a vehicle suddenly have an emergency, there's a car failure, the driver cannot operate the vehicles. Then they can use our app to press the button. Then will be sent to our cloud platform. The cloud platform will send the notification to all the vehicles within the group in the areas. And then if you are one of the drivers, you receive this alert, you receive this notification, you can go there and provide a remote assistance to that drivers. This is the vulnerable road use case for the V2P. There's the pedestrian crossing behind the vehicles, and then you generate the alarm to notify the approaching vehicles. There is the pedestrian actually crossing behind the vehicles. Okay, this is the intersection alarm. Okay, when the vehicles actually approaching the intersection, they cannot see each other because for the long line of sight situation, or they are actually blocked by the large obstacles or large trucks on the road, then there will be a potential hazard for the condition. Then actually our RSU or HKV can relay this information and can generate the alarm to alert the vehicles, the drivers, in order to slow down to avoid the accident at the intersection. Okay, maybe we can play the video now. So enjoy. This is a V2V emergency stop. Two vehicles. Okay, the head vehicle suddenly do the emergency brake, and then you can send the alarm to the rear vehicle. This is the animation to introduce the. Yeah, you can see that. Look at this video. This is the view angle from the rear vehicle. You can see that the head vehicle actually do the braking, and then you receive the alarm from the rear vehicle. And that they do the second emergency brake. Okay. This is the intersection alarm. When two vehicles approaching the intersection, there is a potential collisions, and our RSU will send the alarm to notify the drivers to slow down in order to avoid the collision. So focus on the view angle for the vehicles. It is actually approaching the intersection point, and then actually there is another vehicle rushing from another direction. Yeah, this one. So with this alarm, the driver can actually slow down. But in future, for autonomous driving, you can automatically slow down brake the car actually. This is for pedestrian crossing, the V2P communications. Okay, the pedestrian actually stay behind that gray vehicle. We receive the alarm before you do the crossing. And these are actually some of the GUI features for the future metro. Because we can do the real-time car sales monitoring, we can retrieve the data. The scale is more than 1,000 cars in Europe now. And this is for the trip records. You can select the time, select the day, and then you can do it for the car. You have the trip records, and then you can also replay the trip for that particular specific car. Okay, the heat map is like a statistics that how frequent the car actually visit the areas based on the GPS location. So this is maybe useful for the traffic department to locate where is the most congested area in Hong Kong. Yeah. Okay, so we have seen some of the V2X use cases developed and enabled by our V2X system. Right now, I want to do some promotion from our company. Actually, in addition to the Smart Mobility Consortium we set up with the Huawei and Hong Kong T and also Qualcomm before, there is another program which is called the 5G Smart City Innovation Center, which we are co-work with the Hong Kong Science Park will be hosted in the Hong Kong Science Park and will be launched in this June, actually. The objective is to enhance the Hong Kong 5G research, because as I mentioned, V2X is actually one of the focus of the 5G. Okay, so we will build a 5G lab to enable different 5G technologies and applications. We're using our technologies all the way to build a 5G testbed from the base station, from the baseband solution for the RF, from the management system, for the core network software, from the V2X use cases. And not only the V2X applications, but we also enable different smart city applications like the fintech, the intelligent manufacturing, the public safety, MBIoT. So all these can be enabled by the 5G technologies. And we want to do some prototyping and testing with our partners. So we welcome any industry partner to join us for this kind of innovation center. Okay, so this is a draft look. We are under construction. These are the center entry, and we'll do some demos. We'll do some prototypings. These are the work partners working space. And we also will use the venue to hold some seminar or training session to the public in order to promote the technologies. Okay. So as a takeaway points from you, V2X is actually the 5G technology focused trend with a huge global market potentials. Okay, V2X can actually complement and enhance the existing in-vehicle solutions because it can provide the so-called cooperative awareness between the vehicles to step up the knowledge from the environment. Okay, and it can actually enable different advanced capabilities, applications like the autonomous driving. So V2X is one of the key components to enable this autonomous driving. And actually we have the V2X R&D projects cover an end-to-end system, use case development, all the way from the radio baseband solutions, from the gateway software for the management system, and also for different use case development and applications. And we have set up the Smart Mobility Consortium with our partners in order to, we want to use the V2X technologies to enable a smart and safe mobility in Hong Kong. We will do some trials in Hong Kong to realize the possible deployment of these kind of applications and technologies. So we welcome any industrial partners to cooperate together in this field, especially because we need to have an ecosystem in order to build this kind of V2X and connected vehicles technologies and applications. So this is the end of my presentation. So thank you.
Thank you, Dr. Billy.